Hi everyone. Today we are from Group 10 is going to present our group project for Mathematics for Engineering Technology 2, course code BNQ 10603, semester 2, 2023-2024, and our lecturer's name is Dr. Nurshila binti Muhammad Noor from section 1. And this is our team members. The first one we have Ain Imanina binti Muhammad Asfanizan, AN 230091. Second one we have Dayang Nur Aina Zubaida binti Abang Khalid, CN 230184. Third we have Nik Nur Aina Nadia binti Muhammad, AN 230020. Lastly we have Ummu Atira binti Abdul Malik, AN 230001. The objective of our study is firstly to relate the use of engineering mathematics in our course, which is chemical engineering biotechnology. The second one is to enhance mathematical skill by applying our learning materials in real-life situation.
Based on the question, we know that dy over dt equals to rate in minus rate out. The equation for rate in and rate out is concentration times flow rate, and we just substitute all of the values from the question into the equation below. So we'll get the value of rate in equals to 0.4 kg per minute and rate out equals to yt over 25 kg per minute. Based on the equation, we know that it can be separated, so we can just integrate both sides and we'll get the value of negative 25 ln, absolute value of 0.4 minus yt over 25 equals to t plus c1, which refers to the first constant. Next, to get rid of the negative 25, we multiply it to every term. To get rid of the value of ln, we change both of the left-hand side and right-hand side term into exponential term. Next, by getting rid of the absolute value, we can get 0.4 minus yt over 25 equals to plus minus c3 times exponent to the power of negative t over 25, where c3 must be more than 0. Then we'll get the value of y equals to 10 plus c times exponent to the power of negative t over 25, where c equals to plus minus 25 c3, and the value cannot be 0. So we'll get the general solution, which is y equals to 10 plus c times exponent to the power of negative t over 25. Initially, the tank have no salt, so the value of y and x is equal to 0. So we just substitute the value into the equation and we'll get 10 plus c, where c equals to negative 10. Then after getting the value c equals to negative 10, we just substitute the value of c into the general equation to get the particular solution as shown in the slide above. So to calculate the amount of salt after 1 hour or 60 minutes, we just change the value of t equals to 60, so we'll get approximately 9.1 kg of salt.
Hi, I am Ain Imanina and I will present Part B, Application of Electric Circuit in Engineering. Application from Chapter 3, Second Order Linear Differential Equations with Constant Coefficient. So the question is, find the charge on the capacitor in an RLC series circuit where L equals to 5 over 3H, R equals to 10 omega, C equals to 1 over 30F, and ET equals to 300. Assume the initial charge on the capacitor is 0C and the initial current is 9A. What happens to the charge on the capacitor over time? So from here we could apply L second derivative plus R first derivative plus 1 over CQ equals to ET. And then we can substitute the value that had been given in the question, which is 5 over 3 second derivative plus 10 first derivative plus 30Q equals to 300. And then we simplify, it becomes second derivative plus 6 first derivative plus 18q equals to 180, and then we make it in the form of quadratic equation, which is m squared plus 6m plus 18 equals to 0. And when we factorize, we get m1 equals to negative 3 plus 3i, m2 we get negative 3 minus 3i, and this is applicable in case 3. The general solution for the complementary equation will be yc equals to e to the power of negative 3t times a cos 3t plus b sin 3t. And then we're going to assume a particular solution of the form yp equals to q, where q is a constant. By using the method of undetermined coefficient, we found that q equals to 10. So yc equals to e to the power of negative 3t times a cos 3t plus b sin 3t plus 10. And then we're going to apply the initial condition given in the question. We found a equals to negative 10 and b equals to negative 7. So the final answer will be y equals to negative 10 e to the power of negative 3t cos 3t minus 7 e to the power of negative 3t sin 3t plus 10.
Hi, I'm Dayang. I'm going to explain about the application of control system in engineering, which is the solution of system dynamic in Laplace transform. It can be solved using partial fraction method. A system is usually represented by following dynamic equations. So the question is, expand the following equation of Laplace transform in terms of its partial fractions and obtain its time domain response. The equation for the question is ys equal to 2s over s plus 1 in bracket and s plus 2 in bracket. So the solution of this equation is the following equation in Laplace transform is expanded with its partial fractions as follows, where it will become a over s plus 1 in bracket plus b over s plus 2 in bracket. After that, after expand the equation, it will become a s plus 2 in bracket plus b s plus 1 in bracket. After comparing a and b, a can be determined as negative 2 and b is 4. Therefore, we need to do Laplace transform and substitute the a value and b value into the equation, where it will become yt equal to negative 2 exponential negative t plus 4 exponential negative 2t. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuraina Nadia binti Muhammad. Matric number AN230020 will explain about application that relate to the mathematics. So for this question, I will explain about solving transfer function in control system model. So firstly, we can I will explain a transfer function of a control model, the output signal for all possible input value. So we use the input as x and the output as ys that can be related by transfer function. So from the figure as transfer function as hs and the output ys. So we can use this to solve the equation. So in the domain, the input and the output of control system are denoted as x, t and yt respectively. So we can use the inverse Laplace transform. So we got ht equal to L inverse hs. It called as impulse response. So in the Laplace transform, all initial conditions are assumed to be 0. So from the example I choose, we can given the transfer function of a system is by hs equal to s over s squared plus 4 with the input signal xs equal to 1 over s. So find the output response for yt for the system. So we take the value of s over s squared plus 4 as the hs, and we use the ys over 1 over s as the value. We change the value by the formula. So ys equal to s over s squared plus 4, and we will multiply with 1 over s. So now use convolution theorem to find yt. So we choose fs from the formula. Fs we change s to s over s squared plus 4 gs s 1 over s. So we solve the equation. So we got ft L inverse fs 2. We got L inverse s over s squared plus 4 equal to 2t. So this is from formula. Then gt equal to L inverse gs equal to L inverse 1 over s equal to 1. This is also from the we solve by the formula too. So we got ft equal to 2t gt gt plus t equal to 1. So determine the yt by using convolution theorem. We got the yt, then cos 2t multiply with 1 dt. So change from this is also from the theorem. We got sine 2t over 2. So put the value of 1 over 2 sine 2t minus sine 0, because the value of above we got 1, then the 1 and 0 we can change and put the value, and we got 1 over 2 sine 2t. Then that's all for application in control system model that relate to mathematics.
In conclusion, engineering relies heavily on mathematics since it provides the fundamental for analysis, design, and problem solving. It helps engineers to assure accuracy in their work, maximize performance and model, and simulate complex structures. By fostering interdisciplinary collaboration and driving technological innovation, mathematical principles enable engineers to effectively tackle real-world problems. The application of mathematical concepts is still vital as engineering develops, supporting advancement and quality in the discipline. That's all from us, Group 10. Thank you.